Okay. Good afternoon and welcome to our winter session workshop, Safeguarding Amazonia. My name is João Bill, and I'm a professor of anthropology and director of the Brazil Lab, which is organizing this event together with the High Meadows Environmental Institute and the Office of Wintersession and Campus Engagement with the co-sponsorship of the Department of Anthropology. We are thrilled to have a wonderful group of undergraduate and graduate students joining us for this exciting week, and also members of the larger Princeton community for this opening session. Special thanks go to Michael Mugi and Morgan Kelly for helping to bring this exciting initiative to fruition. We have been most fortunate to organize this workshop in partnership with Tasso Azevedo, founder and director of Mapiomas, a network of Brazilian scientific institutions, civil society groups, and startups that is producing the most complete, detailed, and comprehensive maps of land use changes in Brazil and Pan-Amazonia, and is now applying its cutting-edge methodology to other tropical forest belts. For all of us concerned with environmental justice, the fight against deforestation, and for conservation writ large, the work of Mapiomas is indeed a great inspiration. Before introducing Tasso and his wonderful team, let me say a few words about today's format. In the first hour, we will learn about the methodology, products, and the impact of the Mapiomas initiative. After a period of Q&A, the opening session will end no later than 4:30 p.m. The students enrolled in the workshop will stay in Zoom, and Tasso and the teaching team will review the syllabus and the week's activities. Let me say a few words then about the wonderful team leading the workshop this week. An environmentalist and technology innovator, Tasso Azevedo is one of the most important Brazilian public intellectuals, and we are proud to have him as a Princeton Brazil Lab affiliated scholar. He is joining us from São Paulo. A Skoll Fellow, Tasso has played a key role in the design and implementation of the National Plan to Combat Deforestation and the Amazon Fund, and is now leading efforts to expand Mapiomas to South America and Asia and Africa. As Tasso always says, Mapiomas is a creative teamwork, and we are also fortunate to have with us this week a terrific group of visionary young scholars who are joining us from Belém in the Amazonian state of Pará. Cesar Diniz is an oceanographer specializing in land use and land cover analysis of coastal environments. João Siqueira is an environmental engineer specializing in digital image processing. And Luis Cortinhas is a computer engineer specializing in computational intelligence. We are all deeply grateful to our good friend, Michael Cilia, the director of the High Meadows Environmental Institute, for leading Princeton's visionary efforts on safeguarding the planet. Mike is the Theodora Sheldon Pitney Professor of Environmental Studies and Professor of Civil and Environmental Engineering. So Mike, please, the screen is with you now, and Mike would like to say a few words, and then we will hear from Tasso. Again, thank you so much all for being here with us today.
Thank you, João. I really just have a very few words to say, but on behalf of all of my colleagues in Princeton's High Meadows Environmental Institute, I want to say how delighted we are to be part of this really important winter session course, which includes this public lecture that we've decided to put as the opening event. And as usual, we're especially pleased to be doing this with our great friends at Brazil Lab, and that includes João, Miguel, their whole team, and especially Tasso and his team, who, as João just said, are at various locations in Brazil, but who continue to do just absolutely amazing work that is profoundly important in many ways. And one of the things that we're most excited about is that our students will be able to spend this entire week in this sort of deep dive into the Mapiomas platform And our hope and our expectation is that this will lead to a number of new ideas, new initiatives, new projects, and I certainly expect that this will include new projects that develop within our Environmental Institute in conjunction with our great collaborators. The last thing I want to do is just say a note about question and answer. As Joao said, we're trying to leave about 30 minutes of time for discussion and question and answer period. I already mentioned that to the students that they will participate in the Q&A directly through the Zoom link, but those of you who are watching through the YouTube channel, you should, if you want to post either a question or a comment, please use the chat tool, which is open, and submit through that. We will collect your questions and comments and try to get to as many of them as possible during this time we have for question and answer. All right, with that, I will turn it over to Tasso, who will start this public session. Thank you all very much.
Okay. Like this. Okay, thank you, João, thank you, Miqueias, Michael, and everybody that's participating today and will be participating this week also. It's a pleasure and an honor for us to be doing this together with the Brazil Lab and so on. I think this is a very good opportunity also for us to exchange what we are learning and as we do this project work in Brazil. And it's also an opportunity for us to get insights for other things we could do and we could develop as the same time as we are sharing where we get so far. So so the idea here is to kind of give an idea for all of you of what we are doing, the potential that is there, and kind of give also some inspiration for the next 4 days, which will be very hands-on on the process, the building blocks to actually produce what we produce. So that's what will be the next 4 days. So I'll start like this. So this is a map of the Amazon, and you're just seeing the years passing by since 85 all the way to 2019. And so we're just seeing, the green getting smaller and the yellow and the pink growing, which is agriculture and pasture. So by having this vision of, how conversion is happening in the Amazon, we can get a picture to understand better what is when we see a map like this. And where you see all the accumulation of loss and degradation of forests in the Amazon. So, in one hand, we can say that we still have 80% of forest cover in the Amazon. But on the other hand, we lost 20% of this original forest cover in the last 40 years, basically. So it's happening very fast. So to understand timing is very important because this is probably the fastest loss of forest that we have in history happening right now in Brazil, and maybe it's comparable to what happened in the West Coast in US for some certain period of time in the 19th century. But that's basically very fast. And it's not just that we are losing 20% of the forest, but for the remaining forest that we have, about 10 to 20% at least, it's heavily degraded. So what we really have as the original forest is much less than what we apparently see when we see this massive green area in the region. And so if you look at the places where we are concentrating the loss of forest, and this is a view of the loss of the forest, where the red stuff it's like a more recent loss of forest, and the yellow is the oldest one. You can see how this is growing towards the center of the Amazon. Starts in the border, comes to the center. And when you look at this image, and then you compare with, you can see this in different regions with more details, but when you compare with the maps of the water surface, you see some interesting patterns. So in this case, we are seeing a map here where we separate the artificial water streams from the natural water streams. So what you see here on those dark blue is natural water streams, and what you see in the light blue, the red or pink, and the orange, these are artificial water streams, water bodies. So in the case of the pink is water dams for hydropower plants. The orange is for mining, and all this light blue is reservoirs inside farms that the farmers do. So what is interesting here is if you look at that, you see that there is a lot of coincidence between the areas that you have the deforestation and the areas where you have this immense growth of anthropic dams or dams made man-made. And so we find out 50,000 of those dams just in this region in the Amazon. And what's happening now is that the surface water for natural water streams is actually coming down. So we lost about 7% of the water surface in the last 15 years in the Amazon, which is astonishing when we look to that. And when we don't separate those two categories, it's difficult to understand and to see this change that is happening in the region when you just look at the water surface. So to understand what is in those water surface and if it's natural and tropical, etc., it helps us to understand the dynamics that's happening in the region. So basically now what's going on, we are making dams because it's getting drier where we cut the forest. And as we make dams and the dams are upstreams, less water is going to the natural streams. The natural streams are where you have all the trees that pump the water to the atmosphere and create more rain. So you have less vapor coming to the atmosphere. You have more droughts in this area that is clear cut. And then you have more dams. So it's a kind of we are recreating the machine of the Amazon that creates rain to be a machine that is creating drought. So this is the type of of insight and analysis that we are getting by understanding the land use and land use changes that are happening in the region. Now, I start by this, and also, let's say, another question is that we often have, like, why we are cutting down forests. So why we are converting forests? What happens with those areas that were forests before? So by looking at the data of what is the land use change that is happening, we find out that 63% of the areas that have been clear cut in the Amazon is actually turned into what we call degraded pasture. So this, I mean, I know it's difficult to imagine, but this is a pasture land, right? And then we have 14% that is actually for cropland or more intense agriculture or urban areas and stuff like that. And 23% after it's clear cut and used for some years is just abandoned and is regenerating. So what's the meaning of why we are actually cutting down forests if it's actually 63% is degraded pasture, 23% is being regenerating, and just 14% is being used properly? So the understanding of all those transitions and those changes help us to understand where we should focus our attention if you want to have a, let's say, stewardship management of the land and the sustainability of all the use of the natural resources we have in Brazil. So let me talk about, again, this is just to give an insight of the things that we are actually working with this data, and then come back, give one step back and say where we start, how we start this project, and why we start. So a few years ago, like 10 years ago, I started to work to calculate and to track all the greenhouse gas emissions in Brazil. And Brazil happens to be the 5th largest greenhouse gas emitter after China, US, India, and Russia. And the reason why we are a big emitter of greenhouse gases is because of the land use change. So if you take land use and land use change in Brazil, it responds for about 70% or more of our greenhouse gas emissions. So it's kind of the opposite of what happens in those other 4 countries that I mentioned, where almost 70% actually comes from burning of fossil fuels. So if you want to tap into that, and if you want to help the causing climate change, we need to better understand and better manage our land use, so we can decrease our emissions, which is good because there is a lot of potential to decrease emissions and increase removals if we manage properly the land. So for many years, Brazil has been monitoring deforestation, which is like one path, one process, which is tree cover loss in a sense. And this has been happening for over 30 years in Brazil, almost 35 years now. But we didn't have information on what happens after that. What are the changes that are happening? So it was very difficult back then to really estimate how much is our emissions and how much is our removals from the land use change, and to track this over time. So the idea back in 2015 was very simple. Say, well, we want to know, what is happening on every single place of Brazil, and then I can calculate what are the changes, and then I can calculate correctly the emissions and removals of carbon. So that was like the origin of the project. We just want to calculate better the emissions and removals. And obviously this tends to be a much more interesting, there was much more interesting use of this information apart from just calculating emissions. But in a nutshell, to do so, what we need to do is to go from a matrix of understanding of land use and land use change, that is forest, no forest, to forest, no forest, or no forest, forest, to something more complex, which is to understand all the transitions that are happening. And to do so, the best way and the simplest way to do is to have a map of the country on every year, and then you can compare those maps on any period of time, and then you can understand what are the changes that are happening. So that is the principle in which we want to work. The only problem was that at that point, it doesn't exist in any country in the world such a work. So there is nowhere in the world where people are mapping the land cover every year, because it's too costly, takes too much time, too much people involved on the traditional methods for mapping. But I'm not from the mapping community. That's not I didn't know anything about remote sensing at that time, etc. So my idea was more simple. It's like, what we have to do if you want to make a map for every year. And so we joined a group of organizations that includes universities and NGOs and startup companies to work together to think about what could be the solution for that. How can we produce an annual map of the land cover of Brazil that normally takes 18 months to be produced, and do it for every year and make many of them per year, so we can have an historical vision of those maps. So that was the proposal. So to do so, we organized those groups in a way that we have specialists working in the Amazon, in each one of the biomes, the Amazon, Caatinga, Cerrado, which is our grasslands, the Atlantic rainforest, the southern fields of Pampa, and the wetlands in Pantanal. And so we have groups that understands very well those environments, and also groups that understands about land use, like pasture, like agriculture, urban areas, and so on. So by combining the expertise of all those different groups with expertise on remote sensing and computer science, that's how we put together a team to think about this problem and find out a solution in which we could produce time series in a very short period of time with also something that was not expensive. So what is the approach that we apply to do so? So it's basically, these are the 4 pillars of what we do. So first, we use the Landsat collection. Landsat is a satellite that was first launched in the 70s. And since 85, the satellite from the NASA and the Geological Service in US, they have been making images of every land in the planet, except from some small islands here and there, for about every 17 days. And today it's actually even less than that. But you have several images of every corner of the planet that is being captured since 85 and saved. So there is this big archive of images that in 2008 became a public catalog and free access. And so we have this kind of a time machine with many satellite images. And the way we approach this is that instead of doing traditional mapping, which you take an image and then you design what you want to find, the features that you are seeing on an image, we decide to use this by processing pixel by pixel. So Brazil has 9.5 billion pixels of 30 by 30 meters. And so our approach is, how about if we teach the computer how to identify what is each pixel in each year? And so we can create this map that is just a conjunction of pixels and pixels and pixels that sum up, and then each pixel has a history. And to do so, we use a lot of machine learning, and what we will learn in this next days is how we do this process of going from the image to the machine learning and to produce a collection of maps. And everything is done on the cloud. So it's cloud-based processing utilizing this tool called the Google Earth Engine, which actually without Google Earth Engine, this whole thing was not possible to do it for many reasons. But the main one is that you need so much computer power in different places to be able to process those images that it will not be even possible to do it, especially in Brazil. So this allows us to have teams working on almost 20 different locations in Brazil with the different expertise and so on. And regardless what is the size of the lab that they have, if they're just working alone in a small computer, old computer, new one, etc., they can do the same thing as big labs around the world. So that's the concept. Basically, Landsat, pixel by pixel, machine learned crowd processing. We have a map that starts with only 7 classes in the first collection in 2015, and today we are working with 21 classes and classifying those maps with all those differentiations. Every year, when we do our new collection of data, we actually reprocess everything and produce all the maps again. So not just we are doing a lot of maps per year, we are actually doing all the maps again every year. So it's like something that used to get 18 months to produce one map for 1 year. Now we are doing this every year for 35 years and including more and more and more information. So that's the beauty of this type of way of working. Okay, so what do we produce with that? So the first thing we do is actually have a map for each year, which in 30-meter resolution, where you can navigate over the country and to see those 21 classes the way you prefer. So let's say here I'm going to the center of Brazil in a place where we call Xingu Basin. And then we have this is 85, a lot of green stuff here. This dark green is forest. The light green would be some kind of a savanna formation. Then you have this yellowish, which is a pasture, and you have some pink here, down here, which is agriculture. And as we move to, for example, 2018, we see a dramatic change in happening in this place. So you can move over the years or jump from one to the other, and you see like the change that happened there. And you can also zoom in on anywhere. So basically, you travel in the space and you travel in time, and you also travel in terms of zoom. So I'm just going to this part of the region. What you see here in green on the left side is actually an indigenous reservation, and you see that this is protected, while the area that is outside is actually moving very fast for agriculture. In this case, most of that is soybean. Okay, so that's one thing you can do, is just basically navigate everywhere, and you can also get statistics for everything that you are seeing on the screen. So it's all pre-calculated. We also will learn during this week how we do this very efficiently on calculating all the statistics for any kind of territorial definition that you want. Like, say, if you want to do by state, by municipality, for a specific farm, or indigenous reserve, whatever you want to, you actually can get the statistics there. So you can see how the different classes are moving along the time. You have the table. You can download and use that, or just analyze on the platform. For every information you have here, you can actually see that for different territorial cuts. So, for example, here we are seeing one single municipality. One of the 5,500 municipalities in Brazil is Sinop in Mato Grosso. So I'm just going and zooming in. And this is Sinop in 85. Now we have Sinop in 2017. Dramatic change, right? So you're seeing like this dramatic a loss of forest and a dramatic increase on agriculture and pasture, and also urban area in the middle. This red stuff is urban area. So for each municipality, now you have this history that you can tell. Also here, if you remember, I want you to understand change, right? So there is a tool which we also pre-calculated, where we compare maps of various pairs of years. Like there is, I think, 50 combinations ready to go, and then you can just choose other combinations. So let's say here I'm seeing 85 to 2019, and then you see that everything that is in red here is loss of natural environment. There is some green in the middle here. It's difficult to see, but there is some green, which is like the opposite, like regeneration. But what is most interesting is to understand specifically change that you are interested in. So by using those sunk diagrams, you can choose what change you are interested in. So let's say I'm interested in to understand where are the areas that were natural forests in 85 that now are cropland or soybean, because the new maps we have soybean. And then so by selecting this part of the graph, you come back and then you see on the map only those areas. So now I'm seeing on the maps areas that were forests in 85. Now they are cropland, right? And so you can add some information to get more analysis. So, for example, I could add all the properties in Brazil. So you go there, click, check all the properties, the real properties of farms are plotting there now. And now I'm seeing this specific change on every single farm that you have in that municipality. So, for example, we have rules in Brazil that says that you have to keep 80% of forests in your property. So easily here, you can see the properties. There are properties that just in this period of time, for example, here, they cut much more than 50%. So yeah, probably is not good, right? Or if you are a soybean trader and you commit yourself to not have to not buy from soy that comes from deforestation after 2008, for example, so you can actually get this information there. Where are the places where forests was exchanged by cropland between 2008 and 2019, for example, and then you can right away identify where are the places where you don't want to buy from, right? Yeah, everything you see here, you can also see the image back and forth and understand how those things is playing. That's the satellite image from 1 year and the other year, so you can compare, and so on. So we have this all pre-calculated and ready to be analyzed for each one of the biomes, each one of the states and the 5,500 municipalities, the watersheds and indigenous lands, protected areas, and so on and so on. So we kind of organize in a way in which you can just get the information you want pre-calculated from start. So as we progress with this project, after 3-4 years, and we were kind of stable and we know how to get the data out, etc., we start to think about complementary data, which is data that the people that use the information wants to get, more insights and information that they need to take decisions, especially in public policy. So building on that, we launched in the last 18 months those 6 initiatives, and which is new information coming in. So irrigation, quality of pasture, infrastructure, fire scars, water surface, and scenarios. Each one of them is another layer of information that you could play with the information that we have on just the land cover land use. So for example, irrigation. Irrigation accounts for just 10% of our cropland in Brazil. So it's small comparing to other countries. But it grows a lot in the last 20 years. Basically, it was 1%, and now it's about 10%. And it's expected to double again until 2030. The problem is 70% of the freshwater consumption in Brazil is already linked to agriculture, mainly for irrigation. So the way you decide where you have irrigation or authorize irrigation, that you give the authorization to use of water, etc., depends a lot on how this thing is progressing and changing and moving in the country. So we just make this initiative where we are mapping all the irrigated areas that we have in the country with different methods of irrigation in a time series. So we have what you see here, for example, on those numbers that you have in different colors in the graphics are the estimations of irrigation that we have over the time for different sources of information. And then just to have the time series that we build up by mapping where are this irrigation happening. So then you can understand what is the pattern, how this is developing, where it's developing, and so on. The other product that we developed the beta version for to see if it was actually possible to do it is to understand the quality of the pastures in Brazil. Why this is important? Because pasture is the main land use in Brazil. 20% of the country is covered in pasture. When I say pasture, it's like planted pasture. People are just managing this pasture for cattle. And it's a very, very low productivity. So, and one of the reasons for that is that actually it's one thing pushed the other, is that there is a lot of degradation. But nobody could tell where is the degradation, how much of the pasture is degraded or less degraded or is well managed. So that's what we want to find out, because it's very crucial for the carbon balance, because degraded pasture emits carbon and well managed pasture sink carbon. It's totally the opposite, one to the other, right? So this is the first version. We could make 2 maps to test, one for 2010 and one for 2018, and basically we learned that we still have 60% of our pasture in the country degraded. It varies along the country where we have more or less degradation, but the other information is that actually the area that is degraded come down 12% on the last in 8 years. And that's very important because in 2010, Brazil starts a very massive program to improve the quality of the pasture. So it's an interesting way to evaluate if this policy is actually working, is seeing, what's the quality of the pasture over the time. So now we are moving to have this map of the quality of pasture since 85 all the way to 2020 for this year. Another interesting feature is to correlate, sorry for this is A lot of this is in Portuguese. I don't know why. I forgot to translate. But you got it. So what we have here is we put in the system every information from transportation, energy, and mining that we could grab on. So every road, every power plant, transmission lines, railroad, and everything. You name it. Everything you can imagine about like transportation, energy, and mining, we put on maps, organize the data, harmonize them, so you can actually analyze what happened with the land cover, land use on a buffer of 5, 10, and 20 kilometers of any of the infrastructure that we have in Brazil on those maps. So here we are seeing like the federal roads, federal highways, and then we see what is the buffer along those. This is a 20 kilometers buffer, and you can see the land use in those places. So for example, one use of that, this is Rondônia state in the Amazon, and you see like along the federal roads in the state, that is 85 on the left, 2019 on the right. If you compare the land use change that is happening along the roads, this 20 kilometers buffer, and against the whole state, the speed in which the deforestation is happening and conversion is happening along the roads is twice as the average of the state. So you can then you can do this for different infrastructure types, etc. This is a very new one. We just launched this in December, end of December, and we are working very hard to complete this thing in June this year. So it's what we call Mapioma's fire scars. Obviously fire is a big discussion in US, in Russia, in Australia, everywhere, also in Brazil, in the Amazon. But we are always talking, in our case, we're always talking about, fire events. So this much fire events happen, 50,000 fire events or something. And we want to understand actually what is the area that is affected by those fire events. What is the land cover that is impacted by this fire? What is the frequency in which the fires is happening? Because this is crucial. Like in the Amazon, it's totally different if you have one fire event, and then you have 100 years to recuperate, or if you have one fire event and in the same place gets on fire again in 5, 10 years, it will not recuperate soon. So, and what is the effect of, for example, land tenure when you have a fire event? So, what we are doing is mapping all the fire scars that we have. We complete this for 2000 to 2019, and now we are going back to 85 to understand, where, how, what's the frequency that fire happens in Brazil. And because we have the land cover maps for every year, we can understand also where these fire events are happening, what type of land use, or if the fire event is part of a land use change. You can also see that on the maps. So just to have an idea of the type of data that comes out from that, about 17% of Brazil have burned in the last 20 years, at least once. 17% of Brazil, the 5th largest country in the world. And then from that, half of that burned twice, which is, it was really, really, really surprising for all of us to see that, because we didn't have this idea that accumulated, that's what we are having now. So the amount of forests, natural environments that have been degraded by fires is much higher than what we expected. So, and we didn't come back to 85 yet. So we are going now to 85 to see what we will find out when we have like this whole period. So that's fire. Then we have water. I just talked about the water before, but the idea is that we will have all the segregation of all the different types of water structures, artificial and natural, in the maps by August this year. And but one other thing that we are working for water is that water surface is not a good product to have on annual basis, because water varies much along the year. So we want to find a way to capture that on one image, to capture what is the change that are happening in the water during the year. So we want to go from what you see here on the left side, which is our actual collection that we have now, and and we want to go this for, what you see on the right. For example, this is a monthly map. So we are doing this since 85, one map of water surface in Brazil for each year, and then for each month. And then you can see a map of the year, but actually with the idea of permanence of the water surface during the year, and then during the year, and then you can do this multiple years and stuff like that. Okay, so how I'm in time? Yeah, okay, yeah, some minutes. So the last one is something that we are still struggling how to do it. I know that this is something that you guys love to do, work on scenarios and projections and so on. So we are trying to create something which is a kind of a tool where you will be able to link in this tool, and then you have 5 areas in which you can play with the policies, protected areas, climate policy, roads, economic growth, and urban growth. And then you can see what will be the land use change projection for Brazil in 2025, 2030, and 2035, depending on the decisions you take or the scenarios you choose on those 5 areas. So we're still struggling on how to put this in place to work properly, but it's now almost 800 scenarios that it's being played and organized, because we want to see this be very simple to just go there and select what you want to change in policy and see the results. So anyway, so we're thinking about tools also to produce scenarios to help, especially the public policies. Okay, so how to make this accessible? So you can go to the platform and see the maps and collect the data there, etc. But since it's a very massive data set, we have some mechanisms for simple download of the collection of maps, or download all the statistics that we produce. You can even access the mosaics of the Landsat image that we are using, reference maps, legend codes, and so on. But we also produce this kind of a toolbox to access first all the data that we produce, and then you can download in a specific area, a specific place, a specific time, a specific type. If it's light cover, or you want to have like the map that represents the land use change, whatever. You just choose what you want, and then you can just download the data that you want to have. So this is an application on Google Earth Engine that we actually will also explain how to use that and how to produce yourself. If you want to produce a toolbox for other projects that you were doing, this will be also discussed during this week. So then we have a collection of scripts and codes. So everything we produce on Mapiomas is open and free access. So anyone can just go there and copy and paste and do it and whatever. So we are doing this through GitHub. So a lot of the codes, as the code's getting more like stable, we keep putting them on GitHub for anyone to use. Then we have this algorithm theory-based documents, the HEBG, for explain the methods. We choose to use this type of mechanism because instead of just like describing the present methodology, we use this document to kind of describe the codes at the same time that we describe the history of the methodology. So you can understand how we get to the point where we are today. So why we took the decisions we took, and et cetera, et cetera. So you can see this on those documents. And last, we have some APIs and web services to access the data directly from our data banks. And a very interesting feature that people love it, which is this plugin for the QGIS. So you can, essentially you can just have this plugin, and then if you click on this icon, you basically can push all the information from Mapiomas to whatever you were seeing on your map. If you are in Brazil, anywhere, and you want to push any information from Mapiomas directly into your GIS project, you can do it through QGIS, and there is and we have an agreement now with ArcView to also with Esri to produce also for ArcGIS. Okay, so as we are running, I think I'm running out of time. I would just like very briefly talk about some of the applications that this data have. There is, for the ones that are interested, there is a series of videos that we produce. Like I think there is like 20 videos, short videos, 5 minutes, 6 minutes, with different use cases and how people are applying this data and this information and collaborating with us. But I just want to show some of them. So this is one is a very basic one. You know, how much forest we have in Brazil, how much farming we have in Brazil, and so on. So now we know that 67% of Brazil is natural environment. And then 61% is actually forest, right? We know that farming in Brazil is 30%. It's not 80%, 8% that somebody said, or the president or minister said. It's 30%. It's like normal. It's like the world has 34% and Brazil has 30%, normal. Then we have like the distribution for each one of the different categories. Not getting to that, but then now we know what we have in the different categories of land use and the distribution. Also, we can analyze and look to each one of those classes. So, for example, here I'm just looking Brazil for the eyes of the natural forest. This is the natural forest. Different formations. There is mangroves. There is, forest formations, savanna formations. This is all forest, and you can see that there was this decrease of about 54 million hectares of forest from 85 to 2019 in the country. This is like a German, the size of Germany. And then you can also see how much of this forest is in each one of the biomes in Brazil. Same thing we can do with the pasture. So it's the opposite side. So you see like the pasture is growing towards the Amazon. It's kind of spreading to the Amazon. And it's actually decreasing in states like São Paulo. So if you see here, that's São Paulo. In São Paulo, pasture is going down and is actually moving up to somewhere. So this type of analysis also can be done here. Same thing for agriculture. See, where is agriculture growing? It's actually growing in São Paulo, where pasture is going down. So agriculture is taking over pasture, and then this pasture is moving to some place else. So so you can do this. Follow what's going on with different type of land use classes. Here we see that we lost 87 million hectares of natural environments in Brazil in between 85 and 2019, and 90% of that is lost to cropland and pasture land. And we can see how much of that happened in each year, and how much of that, if you want to know how much of that was what changed to water or back, you can also get this through those analyses. We know how much of this loss of vegetation happens in each one of the biomes. So the Amazon lost 11% in this period. But you see, Cerrado, which is much less looked over, it lost 20%, 21%. The Pampa in the southern fields of Brazil, 21% also. It's a big loss in terms of proportionally is losing much more in the Cerrados and Pampa. Here's another interesting feature. You can understand if the land use matter, the land tenure matter. So here we see that from the total area that we lost in natural vegetation in Brazil, only 1.5% are in protected areas. So really, protected areas works, right? And then the majority of that, 2/3 of that, happen in private land. Although if you see like the amount of forest that we have in private land was not so much, it was just like 20% more than what we have in protected areas. But they have like 2/3 of all the loss of natural vegetation in this period. Then you can see this is a very, very simple vision of Brazil. That's Brazil going down from the natural areas and increase the anthropic areas. And then we can see also this change along the way. So we were losing forests much faster in before 2004, 2005, and then we start to lose slower. And so we're slowing down this in the next years, right? Another interesting data is that because we know how much we have from forest or natural vegetation become farmland or anthropic use, we also know when it comes back. Now we can calculate how much is primary vegetation, how much is secondary vegetation, which means not the original anymore. It's regrowth. So this is a stunning number because we have no idea about that. But at least 9.3% of the native vegetation that we have today in Brazil is secondary vegetation. Not secondary because there was a harvest or something like that. It's secondary because there was a clear cut. Like this area was forest, it was clear cut, moved to something else, and then coming back to forest as a secondary vegetation, which is massive, right? And this is like 5% of the Amazon, 5% of Pantanal. But look, it's 39% of the Pampa. It's 28%. It's 1/3 of the Atlantic rainforest where most of the Brazilians live, right? In the coast of Brazil. Okay, so and there is other examples in water and other stuff that we could use, but let's just move quick here to what we call Mapiomas network. So since we started the project, we always had this idea that if this thing works, it will be really extremely useful, especially for developing and tropical countries. Why? Because that's where land use change is happening. So if you take the land change in Europe, for example, in the last 35 years, is about 5% of the area that has changed somehow. And if you take the same period in Brazil, we're talking about 1/3 of the country has been changing from one land use and land cover to the other. So the things are happening now on the developing world, and then it will be extremely important to understand what are those changes if you want to interfere and have a more sustainable pathway, right? So different initiatives start to happen in different places. Today, there is all the countries in South America, there is an initiative of Mapiomas, except Chile, that we will start this year. And we also have a team working in Indonesia. And this year, hopefully, we want to get into DRC Congo. Also, it's just a question of finding the right partners to work with. And again, it's the same principle. So from Brazil, we don't do maps in any other country because we don't believe in it. Like, remember what I said in the beginning? You need to have the local knowledge of what you are mapping, why you are mapping, what are the classes that are interesting, what are the characteristics that you could find by using remote sensing, what is possible, what is not possible. So the idea is to build up networks of organizations. So in each one of those regions and countries where the project is happening, a group of local organizations is coordinate between themselves, and we coordinate with them to be able to produce this work directly from where they are. And again, this is possible because the Landsat archive is free and open access to everyone, because we have Google Earth Engine that is available to anyone to use, and because we just put out every single code that we produce available so anyone can use. The only rule is that if you create something new, also make it public, available to anyone to use. So very simple. Yeah, so I'll stop here. I think I'm good on time because I think I'd save some time. How we play now?
Excellent.
Mike is not believing that I finish on time, right?
That's right. I'm unprepared because who would have thought that you would end on time? Anyway, fantastic. Thank you, Tasso. That was a whirlwind tour of these absolutely terrific products. Those who have questions, please send them in. I wanted to start with perhaps something related to water. And I had two different questions. Let me ask one, just maybe this will give insight into how you do these sorts of algorithms. But when you distinguish between natural waters and anthropogenic waters, do you do that strictly by looking at time series, meaning something wasn't there last year and suddenly it appears? Or do you look at the sort of spatial characteristics of a reservoir, where you have a thin stream that suddenly sort of bulges out into a big reservoir? Or do you do something else? How do you actually distinguish surface waters between natural and anthropogenic?
Yeah, good question. So Cesar is here and can help because he is basically doing the first experiment that we did was to identify aquaculture. So the first experiment that we did, we have water surface. How about if we separate just aquaculture, separate? How we do that? So, but let's say I would just give one step back and say, we are right now on this process of identifying and stratify all those differences with the team. But basically we use time. That's correct. So it's a very good one. So if there is a place where you consistently didn't have water and suddenly you have permanent water, it's very easy to understand that this is a reservoir, right? But we also use a lot of shape, not shape in the sense of shape versus raster, but shape as a form. So it's the morphology, and so there is very tricky and funny ways in which you can actually cluster pixels and create forms of the clusters of pixels instead of not designing. Like you don't design a form, you just look at the shape of the pixels when they come together, when you group them, and then you can characterize those shapes. And so that's basically, if I'm correct, that was basically when we start to work. That was what we were using. But also there is something new because we are using now also deep learning. It's a little bit different structure because then you can use formats directly on the image, and so that we are experimenting a lot on that on using deep learning. What is the problem with deep learning? It's basically you can't run a deep learning on Google Earth Engine yet. So you have to do this outside. And by doing this outside, so you have to build up your virtual machines and stuff like that. And so it's not as democratic as it is if you are inside Google Earth Engine. So we'll get there, but eventually this will also be incorporated in Google Earth Engine. But the main difference is, then Cesar can help me. But the main difference with the traditional machine learning and the deep learning is that in the machine learning, you basically give samples and say, try to find something like this, right? And then he used the feature space to do that. And the deep learning is the difference that is actually interact with the result and goes back and forth, back and forth, back and forth until he finds a model that will work instead of just like testing tons of trees, of decision trees, and then find one that work. So yeah. So, but basically time and format.
Okay.
One easier way to understand it is to think of the samples instead of pixels, but as objects. So for instance, when you go in your web browser and there is a security measure asking you to tag where's the cat every time you enter a website, and you say, well, that's the cat. So this is working with the image as within the concept of object instead of the pixel value. We do exactly that within aquaculture, demonstrating to the computer what is the aquaculture pattern. And then he learns the context instead of the pixel value. That's the easiest way of understanding the concept, I would say.
So is it the case that much of this anthropogenic water that shows up is for aquaculture?
Actually not. Aquaculture is the main aspect in the coastal area.
Right, that's what I would have thought. Okay.
But inside in continental areas, we have a bunch of different anthropogenic interference. For instance, electrical power plants, they have its own contextual mechanism, and they are different from aquaculture, for instance.
In this case of the Amazon, that was the test that I show you, is actually basically time analysis.
Okay.
So
excellent.
it's because it's dams. So it's dams for mining, dams for, so it's it's just that.
Yeah. We have a question from Jordan. Jordan, you want to unmute and go ahead and ask your question?
Sure. Thanks for the talk so far. It's been really interesting. So I was just wondering, you talked a lot about kind of the past. I was wondering how well you've been able to make predictions about what may happen in the future, if you guys have started doing that, and if you've, I don't know, had enough data to see if you're right or not. And also, I guess I was just thinking, is there a way to predict, where is going to be a tipping point where, if it's, I don't know, if 80% is degraded, then the other 20% is going to go really quickly or something like that.
Yeah. Yeah. So the thing that in the middle of the presentation, I talk about fire, water, then I talk something about like Mapioma scenarios. That's exactly this exercise. So Mapioma scenarios is a team that is working to think about the future. How we could have tools to help people to think about the future in the platform. But as we are a platform that wants to actually serve to others, so let's say there is several groups working with our data, with this data from Mapiomas to produce forecasts, right? Globion, and there is like, I think 4 or 5 groups doing that. Our approach would be like, we want to have something as a tool, something that you could select what are the variables that you want to change in public policy, and then you could see the scenarios afterwards. And we are struggling to find out a way that computationally would be smart to produce something like this. Because when you talk about with people that talks about scenarios, make scenarios, they said, we make a workshop and then we design the scenarios. There is basically 3 scenarios, right? One bad, one average, business as usual, and good one, something like this. And then you pass weeks of deciding what, and then you run the scenarios, and then you have the paper. This is the scenarios, A, B, and C, and that's it. And then I was thinking of something that would be more practical for someone that wants to work with the scenarios. Should be something that you just play the game and see what happens with the scenario. Like, just change. Okay, how about if we have another protected area here and there? What will happen? And then you could see this right away, like not in 2 months, but let's say in 2 seconds, 1 minute, or something like this, right? So I think this is the challenge. So if anyone wants to work on that, we will be more than happy to engage and give that information to us. But just think about something that will be very useful for policymakers. Should be something that they can play and see the results. Play and see the result. And even better, if they could actually choose what they want to change, would be even better. Like you don't preset, say, well, you can change like protected areas and this and that. You just say, pick whatever you want. If you have a data set with time, this thing will just forecast for you based on whatever you have. So
excellent.
Do it, Jordan. You could start this tomorrow.
Max has a question. Max, you want to unmute and ask?
Oh yeah, thanks. I was just thinking about trying to get a baseline for some of these variables. Like you were talking about fire scarring, and it seems like half of the country burning twice a year is a lot. But how much is that actually? And can we make a baseline by either kind of doing like a reverse regression and interpolate back into the past? Or is there some way that we can like sense environmental variables that would indicate like some estimate for how much fire it can sustain? And that kind of works for any variable you could talk about, water surface area, or I don't know, like how much forestation there should be in certain areas with a healthy amount of agriculture, whatever. But I was just wondering, is there a way to get a baseline from time, even when the data doesn't exist?
I think there's 2 questions there, right? One is what we actually map. We map what we actually can, take from the image, right, directly. So when we say that there is this much fire scars, is because we actually see the by the machine learning side, we saw the scars in this period, and this is 17% of the country. So not 50%, 17%, and then half of that burned twice, which means like if I take a pixel, then I can say, oh, this pixel burned at least once in this period or not. And if it burns, how many times it burns during the period? So you can get to the platform and then you can get all those information, like, how many times it burns and what was the land use when it burns. The first time, the second time, the third time, etc. Or what was the land use the year before it burns and the year after it burns, because it may also change, right? So I think that that is one thing. The second part of the question is like, if I understand correctly, saying, can we backcast to a certain period in which you can actually say this would be my baseline? So, for example, I would say my baseline for the Amazon, my dream baseline for the Amazon is the year 72, because in the year 72 was the first time that we have like really big policies to occupy the Amazon. So we know that in that vision, the estimation was that the deforestation at that point was 0.5% of the Amazon. So if we could get a map that could show that, that would be perfect. So there is actually one guy that tried to do that some years ago without any of the tools that we are using today to produce like this. He basically backcast the data, but not using the pixel level. He was using like 1 kilometer by 1 kilometer plots, and then he kind of a backcast on so it would be like, I think it's amazing. If I think it's doable, because if you can forecast, right, using the history, why can't you backcast?
You exactly
Multiply by -1, right?
Yeah, exactly like this. If you can go and create models to the future, then in the same way, but with a different, in mathematics, you can go backward. So yes, it's doable. We are not doing it, but yes, it's doable.
Yeah. The only thing, the thing is, we will learn this during this week. The beautiful of this process is that because you're using the unit is the pixel, you can make any calculation you want with that pixel, and you can use the information in time, the spectrum that you have on the image, right? And you can use also the space where it's located, and the space means also what happens with the neighbors. So there is a lot of ways in which you can play with that. So I'm thinking in terms of backcaching is basically, if you see the history of the pixels on the neighbors, you can try to find a way to explain what happened with that specific pixel, right? Another interesting one is like, in the 70s and 80s, there was a lot of, there was a conversion of natural forest to forest plantations in Brazil. But in the satellite image, like a forest plantation and natural forest in the Landsat is not very easy to identify, to distinguish. So how we distinguish forest plantation from a natural forest, in something that it's pretty similar. So the way we do it is just looking the history of the pixel. So if you have a pixel that is stable as a forest, that's natural forest. And then first they will be cut once, and then it grows. And then after 7 years, you cut again, so no forest, and then you have forest, no forest, no forest. So I can just classify this as a forest plantation, but I can even classify the year that you don't see a forest there. You can say this is a forest plantation, even if you don't see a plantation, because maybe the image wasn't the date that you cut, but the use of the land is forest plantation. So we can use the same ideas, right, to think this backwards and see, when we had the forest before. Anyway.
Mike, we cannot hear you, Mike.
Yeah, it had to happen at least once, right? Okay. Thanks, Joao. From the YouTube group, how are the maps and data being used to inform policy and law enforcement?
Okay. So there is different use, right, from different groups. So let's say, for example, if you think about the water agency, they use the data that we produce to actually identify how is the protection of the water streams on the different water basins where they plan and they give authorizations for management for water use. If you take the energy agency, when they plan and when they have to monitor what happened on the transmission lines, because for example, fire and farming below the transmission lines, you have like this 4,000 kilometers of transmission lines going from the Amazon to São Paulo, for example. You have to keep all those places where this transmission line is passing clean. You need to anticipate where you can have problems that can block energy and create blackouts in the country based on what happens around those towers. So they use our data, for example, to plan where are the risk areas where they have to pay more attention, for example, another different use. Then I will just go to another one, like the health department. So there is an organization called Fiocruz, it's a foundation in Brazil, which work with tropical disease. And so they, to decide whether they need to have a vaccination campaign for yellow fever, it's very important to have monkeys, because usually if a monkey die, you analyze the monkey and see if there is a sign for yellow fever. If there is a sign of yellow fever in the monkeys, then you start to vaccinate everybody around the area, right? But it happens that if you don't have, monkeys, because you don't have the environments for the monkeys in certain region, then you need to vaccinate them before if you have something happen 200 kilometers from them, maybe they have to start to vaccinate because there's no monkeys as an indicator. So they use the maps of the land use to define what are the riskier areas where if they have a sign that they have to plan. I'm just saying those cases because I think they are very curious, and they show that the types of things that you can do and have with this data is very broad. Now, there is some more traditional ones. So for example, the soybean traders, they use this data to analyze whether they have people that convert forests into agriculture in the Amazon. Since 2008, they can't buy, right? So they check using our data if there is new deforestation after 2008 on the areas that they are buying their product. And so on. We have other products that for example, we didn't talk today about something that we call Mapiomas Alert, where we do, very high resolution analysis of deforestation in Brazil. Every single deforestation that happens in Brazil, we are tracking, and we produce reports for each one of them. And this is used by the environmental agencies for penalties and so on, and for the banks to cut credits and so on. So it's in a process. Probably this is our largest challenge now in Brazil is how to push the public sector that is not interested to enforce anything to actually use this data. So most of what we do now is working with public prosecutors, with the justice and so on, and advocacy to push those organizations to act upon the information that is being put in on their hands.
Excellent. I'm looking at the time here. Any last questions from the students? Feel free to raise your hand if you have a question now.
I'm a student of Tasso.
Okay, Professor.
so Tasso, it just occurred to me, and I don't know if it makes sense or not, but like the question of biodiversity, you spoke a lot about the forest protected, indigenous reservations, the forest is protected. You mentioned areas of conservation, as having less deforestation, So I would like to hear your thoughts. Is there any way to think of, quote unquote, mapping biodiversity with the current technology that you have, or could that be a possibility, the loss of biodiversity, for example?
Well, there's many people doing work on this, but it's not using satellite image, but using sensors, in drones and other things that you can use heat, for example, to find out big mammals and stuff like that. So there are potentially some things that could be done. But what I think it's more promising right now is the integration of the data of the land cover land use with the data of biodiversity. There is tons of data out there. So we have right now, actually, this is one of my tasks for this week is to work on this. It's like we have this immense data bank of biodiversity in Brazil. The name is CRIA. It's a coalition of universities and tons of research institutions, etc., we produce this big data bank of everything that you can imagine about biodiversity. And so we are working now to be able to read the data from biodiversity when you are inside mapiomas and vice versa. So you could connect the 2 points. And we find out this because every time we make, we make this monitoring of the papers and work that is being published using the data. Last year was like 250 papers on, peer-reviewed papers and etc. From various parts of the world. And then we find out that most of the papers are actually related to biodiversity, to some kind of connection with biodiversity. So, okay, there's somebody studying the butterflies in northeast of Brazil as an indicator for quality of the environment, and then they use the data from land cover land use to actually identify what is the connection between the chains and etc. All the way from panther analysis, bats, and stuff. So I would think that the first step now is actually to connect those 2 words more, in the easiest way to use the information and play, because the identification of plants and stuff like that is another, and animals is another science, let's say. Now, if we're talking about elephants, giraffes, and stuff like that, which you can see open, it's cool. But I mean, like I'm 35 years in this business, and I still couldn't see a tapir in the forest. I'm trying, right? It's a big mammal, like it's the biggest mammal we have, and I couldn't see one in the nature yet. Yeah, it's they're hiding there somewhere. So it's kind of not that easy to do it by remote sensing.
Excellent. We'll take one last question from Jordan.
Yeah, you mentioned trying to spread your approach. Like you mentioned, you're already in Indonesia doing work and trying to get into the Congo. I was just wondering, like in a place like the Congo, is the main challenge to find partners who are capable of this, or is it more technical things like, I guess, labeling all of the land types that they're interested in, or I guess, yeah, what's the constraint to spreading quickly?
Partner. I mean, you have to find a partner that has 3 things. One, it really understands the country. You don't need to understand too much about remote sensing and computer science. You need to understand the country, what you want to map, and what's the reason why you do it, etc. Second, that it has a capacity to coordinate with other organizations. It's not just like one organization do excellent work for themselves, but just like because they know how to connect, to work with different groups of people, engage with people that are different, and so on. And the third factor is it should be technically strong, not necessarily on doing maps, on anything, but you just want to have an organization that really cares to have something that is really scientific based, well done, that cares about quality of what they're doing. So I mean, we need to find those 3 things, and then there is like several other factors. But I think that the most important ones are those ones. And there is one thing that is key, and that is something that is not prevented, but it's been more difficult in Africa, is that you need to have people that are independent. We don't want to have on the network an organization that actually have to ask a permission to someone to actually publish the data. Because we see this film before, right? So people stay like inside, trying to do the perfect work, and they never publish anything. They never make it public. So that's one principle for Mapioma. So we do, every time we produce something, we put it out before we even publish. Like our first paper in Mapiomas, like the first paper we published, like describing the whole thing and etc., which has our names and etc., was published last year. We just want this to go out and people, because it's much easier for all of you and all over the world to be able to take our data and produce science than we try to actually first have our beautiful science to publish and have in a paper and so on. So we need this kind of attitude for someone that wants to create the project. Like you need to be very generous in a sense, right? But you will do the hard work and you get to the point where we have this immense amazing data, and then you say, you know what, I will just give it out. Anyone can actually, work with this data and produce, and then I will try to do it better the next time, etc. And once I have the chance, I will publish something. But because that's what we want to foster impact, right? So yeah, so we're trying. So if you have any ideas on DRC and etc., we are eager. So we are talk with different groups there, and COVID is very bad because you can't start a relationship like this over the internet, right? Over Zoom. We have to go there. We have to meet the people. We have to spend some time together. Know the different folks that would be interested. Create this sense of community to be part of the work. But we'll get there.
So, Mike, could I just jump in? I know we have maybe 2 more minutes, but just maybe just to ask a question, and then they can come back towards the end of the week again. Is that okay, Mike?
Whatever you say, Joao. Okay. It's perfectly good with me.
I was just thinking about, because you about to work on Pan Amazonia. We know that the Brazilian Amazon is about 60% of the rainforest, right? And you are teaming up with all countries throughout South America, but Chile, but also you're working on Pan Amazonia. So at some point, maybe throughout the week, or if you could just give us a little bit of a sample of what's happening in Brazil, how does that compare with what's happening in the other Amazonian countries in the region? Both, do we see certain patterns, or do we see some striking differences in the Amazonian region writ large?
Yeah. So if you go to the, even the platform, because, like, as I said, it has to be something that has a meaning. So when the group of the Amazon, which includes Brazil, obviously, they meet, they decide for a kind of a set of classes that we will map that is different from the set of classes that we have in Brazil. So that's why we have a platform just for the Amazon, separate. Because you will see the map that makes sense for that group that's working on the Amazon. And then you can see those patterns of conversion of environments that are happening in different ways. So I would say that Bolivia and Peru somehow are closer to what things that are happening in Brazil. Bolivia, a lot of conversion for soybean and pasture and so on. Peru, there is a lot of conversion happening right now. Colombia is a big thing because there is this whole peace process, and one of the things of the peace process is actually to give out land for the ex-guerrilleros, and there is this whole land reform that happening, and with different variations of impacts. Venezuela is a tragedy because nobody knows exactly what is happening there. There's no governance for anything in the environment right now. But also there's not much pressure directly in terms of legal business because there's no investment flowing in. But mining is a disaster in Venezuela now because there's every time you don't have governance, this is what's growing now. It's the same thing that's happening in Brazil, in the borders with Venezuela and so on. Yeah, I mean we could play on, but there is sort of things. But the one thing I will mention that I think is interesting is that at this very moment, there is this whole process of something that we call the scientific panel for the Amazon, and this panel is it's scientists from 150 scientists doing something that we call like the IPCC of the Amazons. Like, what is the status of the science and the understanding of the Amazon and how we could protect the Amazon, and a lot of the information that's being used now for the panel comes from this mapping exercise that we did for the Amazon, because it's the first time that there is a historical mapping of the region also. So, yeah.
Excellent. Thank you, Tasso. We are out of time for the question period. I want to just ask if anyone, Joao or Tasso or any of the Brazil team would like to have any last comments before we sign off on the YouTube channel.
Just to
thank you very much for everyone that was following on YouTube. Was a pleasure. Next year, come to the whole week, if João allows.
Thank you all for joining us. And thank you, Tasso. We really, we are deeply grateful for you and your team, what you're doing, and and also for this terrific, tour de force presentation today. So I think now, right, Mike? So you will close the session, and then the students, all of the students, right, and all the Mapiomas team, and Mike and I and Miguel will continue then with the second part, right? Yeah.
Right. So everyone should stay on the Zoom call if you're on the Zoom call now. Otherwise, Miguel, I think we can declare success. One more thank you to Tasso for a really terrific presentation, and the whole team for all your contributions. I think we're all looking forward to this week. And for those of you out on YouTube, thank you for joining.